Hello, and welcome to Apstra's From Fragile to Agile webinar. So before we get started, let's introduce ourselves. I'm Derek Winkworth. I'm at CloudToad on Twitter. I am a network engineer. I've 2 CCIEs and a JNCIE, and I am the network engineering therapist here at Apstra. Wyatt, why don't you introduce yourself?
Thanks, Derek. My name is Wyatt Sullivan. I'm a product manager here at Apstra. I'm a CCIE. I'm Arista Certified Engineer number 2. You know, we've been doing networking for a while. That's kind of why we're here today, is to talk to the network engineers. We know a bit about networking because we've been up late at night when our networks are down, right? We've had all that fun and experience, right?
No, for sure, many nights.
Yep, absolutely. So, okay, Derek, why don't you kick us off?
Sure. So, Wyatt and I work for Apstra, and so who's Apstra? Well, we're an intent-based network systems company, and effectively what we do is we build next-generation network automation software. And amongst our team, we have a pretty rich history in networking. We have people who have built and ran actual networks of all sizes and types in all verticals, and we have people who have actually designed and built and supported actual network systems like routers and switches and other kinds of network software. We also have, and this is kind of important, we have quite a few people with a comp sci distributed systems background, and it'll become obvious before the end of the presentation why that's particularly important. But one of the things that we can say about that right away is from our inception at Apstra, one of the most important things is we knew we had to come up with the right kinds of abstractions in order to really automate the network in a novel way that's different and actually useful as compared to other and previous attempts at doing this. And what we model in our abstractions or the primary thing is we try to model the intent of the network engineer, meaning, what it is you're trying to accomplish when you're building this network. How do we capture that? And once we capture that, we take that model and we drive the network as a system in a closed feedback loop. Some of you might be familiar with control systems theory. There's a feedback loop in which in one leg you're sort of driving the system, and then the other leg you're getting telemetry or instrumentation back from the system, and we drive that loop across the network as a distributed system from that model of the network engineer's intent. And in version 1.2 of our Apstra operating system software, we've introduced some really significant features that are pretty powerful, and that's really what we're going to cover today in our presentation.
Yeah, I mean, when you do this right, you can automate the network in a way that's just completely useful to the network engineer. Kind of excited about a couple of the demos that we have, because from a network engineer's perspective, I've absolutely been looking for, a tool that helps me beyond, the MRTTs and the WhatsApps of the world that can just show you a graph and not give you that intent that we understand inherently. It just doesn't know. So absolutely love what our product is and what we're trying to do.
Yeah, so the theme of our webinar today is fragile to agile, and it's really a demonstration of intent-based networking with AOS. So what do we mean when we say fragile? Well, there's actually multiple ways to sort of answer that question. Is the network itself fragile, or is it the processes around the network that network engineers engage in order to design, deploy, and support the network? And we decided to sort of answer this question, in, as we said, in a sort of novel way. That's actually the result of which is we've come up with a way to automate the network, and that network engineers love. And and this has really been our driving approach to AOS since the introduction of our company. And in 1.2, we've introduced really significant features that address the fragility question, whether it's the network or the processes around the network that network engineer teams engage in their day-to-day activities. And yeah, so that's really what the webinar is going to be about today. At any time during the presentation, if you have any questions or comments, you can certainly tweet them. We're monitoring that. You can tweet us at Apstra Inc. on Twitter, or you can tweet at me if you like at CloudToad. You can also, underneath the presentation, there's a button you can click to submit questions. And we're not going to answer questions during the presentation, but we'll have a Q&A session at the end where we'll answer them. So if you have any question during the presentation, just type it right away into the thing below, and then we'll get to it at the end.
Yeah, absolutely. Feel free to heckle us, ask us questions, distract us. Getting your questions and answering them is absolutely something we want to do, and makes for a better webinar when you guys actually ask questions and we get to answer them. Okay, cool. So I'll tell you what. Let me talk now. Let me talk to what makes a perfect network engineer. So as I was sitting, excuse me, as I was sitting putting this together, I kind of tried to think through, like, what would I go through in an interview process? What are the questions? What am I trying to do when I interview a network engineer? And I came up with these 3 or 4 little things that typically have been asked and looked for. Number one is a network engineer can Google anything with uncanny results, right, Derek? Like that's what we do is we can Google great.
That's right. Google is our #1 tool, actually, as network engineers.
Yeah, you're right. It's a tool. That's exactly. It's a tool, and we can Google like madmen. 2, he intrinsically understands the system, right? You get questions like, tell me how BGP works, tell me how OSPF works. You're not really trying to get if they know BGP or OSPF 9 times out of 10. You're really just trying to find out, do they understand how the distributed systems work? Like, what are the problems that come up with it? What are the things that work and don't work? 3, he doesn't cause network outages in real time, right? Like, he's a prediction machine. He knows when it works. He knows he creates configurations, and he is a trusted person to work on that network because he knows what the results are going to be based on his knowledge of the system, based on what he knows of the whole system. And then 4, he's trustworthy, right? Like, he knows his command line utilities. I mean, really, this is just a poor test for number 2, that he understands the system. But we always get questioned on how do you enable BPDU guard, or how do you add a VLAN without taking down the entire trunk, and those type of things. What the network engineer is never really questioned on, though, and maybe he should be, are things like how many network devices can you manage? How much can you reduce the cost of a network service per device? Or how quickly can you deploy a VLAN? Or can you put a device in and out of maintenance with no downtime? Those type of things we don't get questioned, but those are real day-to-day things that keep the networks up. Maybe he should be. So the next generation engineer might need something else, and the next generation engineer has to compete with the cloud. And what I mean by that is he's got to be quick, right? He's got to be faster than the cloud. All our enterprises and Web 2.0s, the CIOs, the execs, the business use cases see the cloud and say, man, I can deploy it quickly, I can deploy it fast, and I can get things up and running, and I don't have to wait 2 days for a VLAN to be added. So the new network engineer, the next gen network engineer, has got to be quick, right? He's got to be able to do it as fast, if not faster, than the cloud. 2, he's got to be everywhere. He's got to make changes at 3 a.m. or at 1 p.m. in Beijing and Wisconsin at the same time. our networks are global now. The network has increased in size in the past 10 years by orders of magnitude. It used to be you can manage your network in your one office with your 2 or 3 racks. Well, now you've got racks in the cloud, you've got racks over in Wisconsin, you've got racks over in Europe, and you've got to be able to be up and able to troubleshoot them all at the same time. And then 3, he's got to be agile, right? He dodges bullets and outages in real time, like picture Neo in the Matrix, like dodging bullets, right? We've all taken out a network before. Heck, I know a guy named Blackout. At least that's his nickname. You wonder kind of how he got that name, right? Derek, I'm honestly kind of a bit disappointed because I didn't get a nickname when I took out a colo back a few years back by putting in a quote-unquote new switch that became the VTP primary. Now, good times, right? I now use VTP as a cuss word because, if you put a switch in and it decides that it's the primary, then now it removes all the other VLANs on all the other switches. I took out VLANs in approximately about 50 or 60 switches and took down a few hundred or a few thousand servers for a good hour while I tried to figure out how to restore that. So I didn't get a nickname. Derek, what about you? You got a nickname, don't you?
Yeah, I do actually have a nickname, number 94. I was number 94 for a while at a previous employer because I took out an organization, all 94 sites of an organization. I'll just leave it at that. Actually, I won't go into too much detail because we have something coming out soon in which I go into greater detail about how that outage occurred. It was pretty terrifying. If you're a network engineer, I would definitely look for this coming because you'll cringe. It's cringeworthy.
Appreciate someone else's struggle.
But yeah, exactly. And it was one of those things where I'm pretty sure I was sweating continuously for about 20 or 40 hours at least. But that outage, I was already a CCIE by at the time that outage occurred. And that was one of the more humbling lessons is, even with a lot of experience and certification, it's very easy to take a network out if you're not two things: if you don't understand what the network should be doing as a whole, and 2, if you're using tools which really aren't the right tools to automate tasks in the network. And that's sort of what happened. I was following procedures. I was using designated tools, but the truth is the kind of automation that we were using just wasn't appropriate for network automation.
Yeah, absolutely. The certification doesn't make a network engineer, right? It's definitely the tools he has and the wisdom he has and experience and keeping things up. Now's a good time to mention the poll, right? We've got a poll, and we're going to put it out. If you're a network engineer, have you caused an outage, a major outage in your network before? I'm gonna make a guess that poll is a resounding yes, but maybe we're wrong. Maybe we're just 2 people that shouldn't be in charge of networks. But no, So we'll throw that poll out. We'll get votes from the audience, and we'll see the results. Okay. So back anyways to what we were talking about. So these guys, these new network engineers, right? Quick, everywhere, agile. They're the new breed of network engineers. Okay. They're really just us, but they're us with tools, right? With better tools to be able to do things, wisdom, and whole 9 yards. So let's get back to Googling. Google how to build a private cloud, and you'll probably come up with what Mansoor, Sasha, and David, our founders, came up with about 3 years ago, like a big fat zero. Sure, Microsoft, Amazon, Facebook, Google, they'll all rub it in your faces about how awesome they are and how they've made a great massive network and how antiquated you are using your old CLI command line and hunched over a computer. But give a network guy a bone, right? And give him a little help. Like, that's a bit of a tough Google search query, right? So enter Apstra. AOS is a distributed operating network system, right? And it manages the underlying vendor OS. And then it builds an intent based on your blueprint and based on your input that provides specific telemetries and configurability designed to that intent. Okay, so that's a mouthful, but that's what AOS does. AOS helps this distributed system to give you, as the network engineer, manageability, telemetry, feedback in that closed loop fashion that you just don't have with the tools that are out there today. Okay, so how does that translate into margaritas on the beach for you and your CIO? We've picked some experiences. We've picked about 3 experiences that we as network engineers have had, and we're going to kind of show you what it would have been like if we had invested in a tool like AOS instead.
Oh, provisioning racks. So in this demo, we're going to add a rack to an existing data center network, and it seems like a simple enough activity, but a lot of things can go wrong when you're provisioning a rack, and effectively when you're adding a rack, you're adding a switch or 2 switches, if there's 2 in the rack, to an existing network, and what if you put a device in there without the right operating system on it, or what if it has some default config or leftover config from a previous install that you haven't accounted for, or what if you fat finger some numbers in there, protocol priorities, interface numbers, etc. There's a lot of things that can sort of go wrong, right? Even cabling, right?
Yep.
Maybe you didn't cable it right,
Yep.
and AOS can help us with that. So, Maya, why don't you show us?
Okay, cool. Now, just for candid and honesty purposes, I did record these demos back early this week. They're live demos, or they're real demos, but they got recorded earlier this week. So we're not trying to, pretend that we're doing this live real time. But I just wanted to state that and let you guys know that these were done real. They are real demos. Okay. So let me start here by talking about this network. So you've got a network, and you've got your spine and leads already deployed, but you've got a new rack you want to deploy. So this rack leaf 4 here, it's not deployed, not put in anything. You might have 5, 6, 7, 8, 9, 10 racks, whatever. For this case, we just had the 4th, just for the demo purposes. But you might have another half a dozen racks or 10 racks or 1 rack to deploy. So how are we going to do it? Click on it first. Go to your properties, look at your telemetry. You can see that I don't have this thing deployed yet. And then we need to find a serial number. So we got to figure out what the switch is. Okay, so we'll go into the devices, and we'll look at our devices. And I've already done the first step of this. It's in a maintenance mode right now, but this device might come in through our AZTP or might be in a quarantine state or something like that. But I'll take the device out of maintenance. I'll put it in normal. And when I do this now, it will actually go into a ready state, or a state that's available to be deployed. This device has no config on it. It's just ready to be deployed. It's available for use. Great. Okay, so now let's go back to my blueprint. I'll click on it, go find the rack that I'm going to apply this to, the rack 4. We'll go into a staged environment now so that I can do this in staged purpose, and so I can stage the deployment. I'll click here. I'll now go to the serial number, and I'll find that serial number. AOS knows that there's only 1 device that can fit this expectation based on the intent. So I'll now click on this, leaf 4, and hit save. Okay, and now it's going to be ready to be deployed. Now, I'm going to first put it into what we consider a discovery or a ready state. I'm not going to deploy it just yet because I want to make sure it's all cabled correctly without any potential problems of killing out my distributed network. So go to a ready state. Currently, it's not assigned. Hit commit. We're good to go. So now in those 2 or 3 seconds it takes for me to actually say something, config gets deployed on the device that allows it to start pulling the telemetry based on the intent that this device is now not in service, but in a discovery service, so in a discovery mode. So you can see I've got a couple anomalies on the right side. I've got some cabling anomalies. Maybe the cabling's not correct, but in this case, it's just waiting for the telemetry to come back from the device to say if it's actually cabled properly or not. So you look here, you can see great, cabling is good. I have all the cables the way we expect it to be. If you look here, I can show you, yep, cabling is right, correct, it's going to the right location. Look at my telemetry, you can see stuff like the config. The config is a basic config. I don't have any IP addresses on it or anything that would cause any major outage problems. It's just in the discovery mode right now. Okay, interfaces are up, things are the way they should be, I'm happy, I'm comfortable, LLDP is good, right? I have swap 1, swap 2 is connected to spine 2. Yes, that's exactly what's happening. By the way, it's a Cumulus box right here, that's why it's swapped. It could be an Arista or a Cisco or any other device that for a vendor agnostic approach. But in this case, we did a Cumulus. So click here, go back to my stage. I'm ready to now put it and deploy it into service. And normally this would be a really long, painful, massive operation. I'd have to figure out my configs, copy, paste, do it in a major maintenance window. But while I'm here, I'll just click deployed, click the little pretty check that says yes, go to my uncommitted. Look, I'm taking it from a ready state to a deployed state. Yep, that's exactly what I want to happen. So let me hit commit. And you can see that it takes about 3 or 4 seconds for things to actually get configured. Now, telemetry has to come in, BGP has to work, routes have to be correct. You can see that my BGP telemetry quickly came up, my routes quickly came up, and in the 6 seconds it takes for me to talk about all this, the device is deployed, active, ready to go. I can look at the telemetries, I can go in, I can validate that everything is the way it should be. If you go to telemetry here, I can show you that, like, for instance, my config is a fully deployed config. IP addresses, BGP configuration, whole 9 yards gets pushed to it because now I know that I'm ready to be deployed or I'm deployed. I can see I've got specific BGP telemetry, I've got route telemetry, I've got very specific telemetry that matches the intent of what I expect the network to do. So now I no longer have to interpret the intent from some other tool. I can actually see exactly what I'm looking at. Cool?
Yeah,
Right,
that's
Derek.
very cool. One of the things that that we didn't actually show there is before, at the very beginning, before we even had that first screen where you have to make the device active. We have a open source project called Aon ZTPS, and when that device booted, it ensured that the right operating system was on the device before it registered to the Apstra operating system. So, I mean, that's what you just saw is that it validated that the operating system on the device was right. It checked cabling, and and then after all those things were okay, it deployed the forwarding configuration onto the box, and then validated the subsequent state.
Yep. And to give another plug for the Aon ZTP stuff, if you guys go to github.com/Apstra, you can see the stuff that we've open sourced, and the ZTP server is fantastic. Vendor agnostic approach to a ZTP server. So fantastic addition to be able to use AOS. And you're right, I skipped through that whole process, but it's a nice, easy process to get a device in there.
Yep, and we'll actually we'll add a link to that GitHub repository at the end of the it's not in the attachment and links now, but we'll add one at the end of the webinar.
Cool.
Oh, device maintenance. So so let's suppose you have your network, right, and you have a device that you have to do maintenance on for whatever reason. You got to replace it, or you have to take it out of service and do an upgrade or some kind of firmware upgrade or whatever it is you're doing. If you were a proper and very disciplined engineer, there would be a sort of stage process for both taking it out of service and for putting it back in service. And a lot of mistakes can be made during this. A lot of mistakes are made during this process, either taking it out or putting it back in service. And with AOS, we can do both those things in a controlled and safe manner, and that's what we're showing you here.
Great, perfect. Okay, so let me start here, and let me show you what we're doing here. So this is device maintenance, and unfortunately, device maintenance is pretty quick and pretty easy from AOS. So instead of actually showing you AOS at first, let me show you what I used to do, and you may do this or you may have done this in the past. Pull out my big spreadsheet, right? I pull out my spreadsheet, I'll start to look at it, and I have to prepare everything for a maintenance night, right? 2 a.m. in the morning, I have to make sure I have everything ready. So what do? First thing is I grab my live config. What is my current config? What does it look like? make sure I have it so that if I need to revert back to it, I can do that, and I can use this for a good validation point. So I copy and paste all my config, make sure it's all the way it should be. Good. Now what's my next step? Well, my next step is, well, what maintenance code do I need to paste? What do I need to paste to get it into maintenance mode to do the next thing? So I put all the maintenance code here I needed to, and actually there's probably a whole lot more I need to, but I was too lazy to actually fill it all out. But yeah, so you have that. And then you have maintenance config that you expect to see after you've done these pastes. So do another show run, and then you do some validate maintenance. I need to do some pings. I need to do these tests, and these are the expected outcomes after this test. Okay, so that's what I would do. I would then do this. I would take a deep breath, drink some coffee, 2 a.m., psych myself up, and then I'd do that. Then I would go to my cacti graphs after I paste all this stuff, and I would make sure, yes, I did lose the communication to the spine that I needed to. On the other spine, traffic did increase. It increased, right? Nope, that's the wrong one. It increased there. Yes, great. I had traffic increase where I expected it to. So you can see that I did a whole lot of interpreting on, what I needed to actually know. I wanted to make sure traffic flopped over correctly, and, I'd have to interpret that based on the tools I had. I'd do some pings, make sure things are up. Yay, that's up. Yay, this is up. Yes, that's valid. That's exactly what I'm looking for. Okay, good. So, you go through this whole process of trying to predict what you need to do those next steps. And always really fun, good times process to try to make sure. Okay, so enter Apstra, enter AOS. Let's do this if I had AOS as a tool. So let's go to Spine 1, and let's say we want to take it out of maintenance mode. Now, what I'm going to do is I'm actually going to do this with real traffic to show you what it is and what happens. So if you look at it, I've got swap 1 and swap 2 on Spine 1. This is Spine 1. I'm showing the traffic across it. Good. And then I'm going to cause traffic. I'm going to create some traffic, 1,400 bytes of traffic every 50 milliseconds. Good. You can see that swap 1 is transmitting, so I'm receiving it in on swap 2. So swap 2 is receiving the traffic, and I'm transmitting it back out swap 1 to go to the leaf. So great. I've got traffic going across this device now. So let's take a look at what actually happens. Just started the ping, so we will do this. I'm going to take this device, and I'm going to move it into a maintenance mode. So I want to undeploy it. Yes. I then go to my uncommitted, and I say commit. Definitely want to do this. And let's see what happens. Traffic dies down immediately. I don't have the traffic anymore. And what's happened? Well, in the 400 or 500 milliseconds, I do have a little bit of loss as traffic's cut over. But that was, less than a second worth of loss. As you see, traffic is back and online, and it's not going through Spine 1 anymore. It is now going through Spine 2, and things are the way they should be. Didn't lose traffic much at all. I've now got 4 devices in service, and I've got 1 in my maintenance mode in discovery config. So that took me literally seconds to do, right? I didn't have to go through all that process. Now I've got a spine that is in maintenance mode, and AOS knows it, understands it. All right, great. So now I need to put it back. Let's deploy it. I've done my config. I've done my upgrades, whatever. So now I go to deploy. I click here, change, commit changes, and sure enough, didn't lose any packets as I put it back in service. Make sure I have traffic. Yep, traffic is now back up. I'm transmitting on swap 1. I'm receiving on swap 2. So everything's back to the way it should be. I just saved myself about 8 hours of sweat and stress and pain, and I probably now need to go to the gym because I didn't work out and have all that stress to help me burn calories. Or maybe I should just be drinking a margarita, right?
Yeah, I would go for the margarita. Drinking margaritas is preferable to sweating over network changes. Yeah, absolutely. Yeah. So, I mean, a lot of mistakes can be made in that process when you do it manually, and a lot of the same mistakes that can be made when you, like, for instance, when in the previous demo when we add a device, right? If when you put that device back in, if you had made configuration changes, you could have done something wrong. If you had upgraded it, it could be the wrong, device operating system. There's so many things that could go wrong during, in in that window. And in the process of taking it out and putting it back in, maintenance, there's lots of things that that could also go wrong, right? If you make temporary changes in the network for this maintenance in order to accommodate or minimize the impact of it, what if you do that wrong, right? There's so many things that could go wrong, and with AOS, you can do it safely.
Yeah, absolutely. So what's next?
Yeah. Do you get up or go back to bed? So if you're a network engineer, then this is a question that variations of this question that every network engineer is familiar with. At 2 or 3 a.m. or whatever time it is, you're trying to sleep, or you're drinking that margarita or beer, and you get that you get some kind of alert message, text, phone call, something telling you that something is potentially wrong with the network. The first thing if that you're hoping isn't going to happen is that you have to get in your car and you have to drive somewhere to fix something, and that's no good, right? And
Yep.
So how can you know if that's what you have to do? And AOS can actually help you answer that question. It can help you answer the question: do I have to get out of bed, or do I have to stop drinking this delicious beer and start working on this, or go somewhere? You shouldn't go somewhere if you've been drinking.
Yeah, because you've been drinking a beer.
Yeah.
My wife actually still pokes fun at me, makes fun of me for the times when my BlackBerry, she called it my Crackberry, would go off at 1 a.m. in the morning, and would keep going off till 2 or 3 a.m. in the morning, and I'd have to constantly be checking the alert messages to see if it's something that I actually should get up and worry about, or if it's something I shouldn't worry about, right? Those false positives that constantly would come in. So maybe AOS can be something that solves that for you. So let's take a look at kind of what that would look like, okay? All right, so everything's up, everything's good. I've got my network ready and all deployed, pretty, everything's live, got traffic across it. So now I'm going to cause an outage. And I'm not going to just shut down a device because that's too easy and that's too clean. So what I've decided to do is I'm going to actually block all of the BGP traffic on my spine. That seems like a pretty painful. Let's pretend it's a bug that's causing BGP to die on my spine, and oh crap. So of course I do get woken up. We can't solve that problem, but the question is how quickly can we get you back to bed? So you get up, you're groggy-eyed, you look at it and you see all this red, and yes, absolutely, the network is not working as it intends to be. But if you don't have AOS, you go here and you look and you're like, oh crap, I got up too early because there's no traffic stats. These traffic stats happen every 5 minutes, or so I don't know what's going on. So then you kind of would have to go through and manually start to iterate through the different things that could be wrong. And that's our typical life as a network engineer, right? We iterate, check this, check the next step, whole 9 yards, look through things the way they should be. Okay, well, let's say you have AOS. Well, AOS sure shows I have 4 devices that are not the way they intend to be. They're missing stuff. So let me look and let me see if I have impact. Do I have any network impact? So I know I should have a default route here on my leaves. So let's go take a look and see if the leaves are the way they should be. At least do I have partial intent working. So I'll click on my routes and I look. And sure enough, my default route is still there. I am missing a route, right? There is something wrong. I'm not saying that. But I do still have the network working for my customers or for my servers. Good. Okay, I've got a partial network up. That guy is fine. Let me also check the endpoint where the external connectivity is. Let's go here and make sure it's got the default route still working and still out. Make sure everything's the way it should be. I do have 1 BGP problem and 5 route problems, so let's see what they are. Sure enough, my default route is working. It's the way it should be. Okay, good. Maybe I can actually go to bed, right? Emergency 2 a.m. in the morning operations are problematic, can cause problems. Doing something at 11 a.m. when everyone else is up is great. So let me look at my anomalies. Let me look at my dashboard. Let me see if this really is impacting, or if this is something that is. I do have a high available network, so maybe it's just a partially down network, and I can restore things in the morning when I get up. Look at my spine. I can see, sure enough, I've got problems. I've got all sorts of routes down. I've got BGP down. Yep, I've got all sorts of problems. It's most likely spine 1's the problem, but that's fine. I can have problems on spine 1. I don't have any end user devices on spine 1, which is fine. But so my network is up and it is running. It's not in perfect state. We do know that there are problems, but we are to the point where I can actually go back to bed tonight, sleep, finish that beer you were drinking, and then in the morning when my boss is up, I can tell him what the problem is. I can troubleshoot the real issue, find out that it was a BGP bug, and open a case back with Cumulus or whoever it is. I'm not saying Cumulus has bugs. Open up the bug with whoever it has, and then I can deal with it in the morning when I am on full energy and full alertness and not at 3 a.m. in the morning. Make sense?
It makes sense to me. That's if I can go back to bed or have another beer or play another round of my favorite online multiplayer video game, that would be preferred to having to work more.
Yes, very good point. Cool. Okay, good deal. So, you know, those are the 3 demos we have for you guys. Really, AOS is tying it back into Google, right? We talked about Googling and how that's like the #1 thing a network engineer does. That's kind of what we're trying to do. We're trying to give you some network insight on demand. And what do I mean by that? I mean, you know, ask AOS, hey, AOS, should I actually get up or go back to bed? Now, of course, we can't actually, you know, open up an Alexa prompt and say, hey, Alexa, does AOS think I should go to bed? You know, we're not there yet, right, of course. But if you learn the lingo, if you look at AOS, if you learn that, AOS has the whole truth, and we can get the answers we want without having to manually iterate and step through to find these answers, right? You know, don't get me wrong, we're on a path, we're on a journey. We are going to get there to the point where network engineers have thousands of telemetries on AOS. AOS can correlate and push things down, but we're not there right now. Right now, we have a very valuable tool that helps the network engineer decide if he needs to be up at 3 a.m. or needs to go back to sleep, right? And this is what we believe can get you from fragile to agile, is AOS, an operating system, a tool that helps you get there. So back to you, Derek.
All right, so we're going to go ahead and answer some questions. We did get a few questions in, and I just want to remind everyone that there is we have a poll you can participate in as we're talking. We have a question: have you caused a major data center outage? Absolutely. You know, please feel free to answer that. It's yes, no, maybe. And we'll share the results when we're done.
You know what? I think they're actually being live shared, and it's interesting, Derek. We've got 50% yes, 41% no, and only an 8% maybe. Really, only half the people have caused major outages. Looks like it's not everybody.
Yeah. I'm going to go ahead and say that maybe means yes, and that 58% have caused outages so far.
Okay, maybe.
All right. So first question is, let me see here. We have a couple. Do you integrate with existing DevOps tools or IPAM systems? IPAM. So IPAM systems, for those of you who are not aware of what those are, they're it's a tool for, you know, keeping track of you know, how you allocate IP addresses in your network. And, you know, do we integrate with some of these things? We do, actually. In fact, we have a webinar that we co-hosted with Ansible, I believe, like last month. That talks all about our integration with how the two, Ansible and AOS, are integrated. So if you want to check that out, just go to our website. And there's a link there for webinars, and you can and then you can watch that on demand. Again, that was co-hosted with Ansible. Quite a bit of work went into bringing those two things together.
Yeah, and it's
And
really spectacular to watch it work like that. Watch it work together.
yeah, and that definitely goes with the theme. DevOps is all about, going from fragile to agile, I guess, right?
Yeah,
To,
you're right. You're absolutely right. Yep. Okay, what other questions?
so do we have, we are deploying Docker. Do you have any help for me? How does AOS integrate? Actually, we do have
That's
help
a
for
good
you.
question. Yep.
Yeah, that's a great question. AOS, so AOS manages, the traditional network devices. When network engineers think, what does this manage for me? It's, router switches, stuff like that. But also, it can manage the routing stack on hosts, as particularly, Linux hosts. So if you're running Docker on
Yeah.
Ubuntu, for
Yep.
instance, you can actually put an AOS agent in the hypervisor, and it'll ensure that the routes for the containers are being injected into the network. There's actually, if you want more information about that, you can contact us, or you can go to our website. We do have some material around that, in particular and with respect to our work with our integration work with Cumulus and their routing on the host stack.
Yeah, we actually did something about that with Cumulus, and it's really significant because sure, we're managing 18 networking devices, but you might be managing 1,500 routing instances on servers if you're doing Docker. So a tool like AOS is phenomenal to help you as a network engineer scale. Great question.
Yeah, for sure. All right. Do we have any other questions?
Nope, looks like we don't. Okay.
All right. Well, so if so what is are those results live, by the way, or the results are still the same ratios? So 50% yes, 8% maybe. So that means 58% yes, 41% no.
I like the
I
maybe
can, yeah. Yeah, I don't. I probably caused way more outages than I remember, to be honest. But
oh, so you're saying
or
even the 41% probably are not correct in their answer, that they don't remember them?
yeah, we'll say 20% have recollection difficulties. All right, so all right, so I don't know. Let's move on here, right? So
Yep.
We have another webinar coming up. It's all about going into greater detail about the Apstra operating system version 1.2. It's and all of these sort of operational abilities that it enables, as well as other very cool things. This is a significant release for us, and the network engineers who have seen this under NDA are very, very excited about the things that we've opened up. We sort of opened the hood on AOS in this release, and it creates some very, very powerful abilities or capabilities for network engineers to leverage. So it's on Wednesday, June 21st. So please go to our website and sign up for it. This will be a great webinar.
Fantastic. Okay, and then what's next? Cisco Live Party.
Yeah, that's right. So, so we're going to be at Cisco Live all week. And if you want to stop by our booth, it's booth 2925, right? So write that down.
Yep.
If you're going to Cisco Live, 2925, and stop by and see us. If you want to actually reserve time with us, for instance, you can reserve time with me, Cloud Toad. Then go to, or Wyatt or anyone really. Just go to our website. There's a form you can fill out, and you can reserve a time slot for us. Otherwise, swing by the booth and talk to us. We can talk more about the product and show you some cool stuff. And more importantly for me, it's Las Vegas, and there has to be a party. We have a party June 26th. That's the Monday, from 7 to 9 p.m. at Mandalay Bay. You can sign up for this again on our website. It is co-hosted by Apstra and this is very cool. Packet Pushers, and I'm sure most of you know what Packet Pushers is. If you don't, it is the most important website on the internet for network engineers. It has in terms of news and content and technical discussion. They have
Yep.
a number of different podcast series, and they have new articles every day about everything from network engineer life to to technical things like how to do different things with different switches, routers, firewalls, stuff like that. It's a very cool site, and they'll be co-hosting this event with us, and it'll be this is going to be a fun event. The intent to party with self-operating networks. So please sign up for that if you're going to Cisco Live, and I will definitely see you there. We will definitely see you there.
Yes, yes, we will both be there, and we will see you there. Yep.
All right, so don't
I guess
forget.
that's it.
Yeah, that's it. Don't forget to follow us on Twitter at Apstra Inc. You can also follow us on LinkedIn, just /company/Apstra. We also have a Facebook page you can follow if you prefer that. If you have any questions, you can message us on any of those platforms, or you can email myself at it's Toad TOAD at Apstra.com, or you can email Wyatt at Apstra.com. Thank you for your time. We actually are very sensitive to people's time, and we didn't want to take up the whole hour, so we'll give you some of your time back. Yeah, 15 minutes back. And
cool.
I hope this was informative. So,
all right, thanks, guys.
Take care.